Gasket exam cram session, video 31. Okay, so pipe threads that are not perfect shall not be used. Okay, where the manufacturer's weld opens up during cutting or threading, that portion of the pipe shall not be used. Before we get to the table, you're threading. You're threading with your 12R, the stock. And you keep, at first everything's going good, right? You set up the machine, you're cutting, threading, guys are taking the pipes, the lengths, going up, doing their thing, a nice assembly line going, a nice rhythm going. And then after a while, it's like, the threads are starting to get all gnarred up, all ugly. Okay, so you change, you go for maybe a fresh drop head or a second drop head you got. You start, everything's good. And then as you're getting your rhythm going again and work's progressing, you start noticing, the threads are getting a little gnarled up, and it's like you're thinking, gee, the dies don't last too long. It's like, it could be the dies, but more than likely, here's what happens. Okay? This could happen to any dies, but usually you see it in the 12R, the drop head. You see it when you're using the 300, okay? You're setting up and you're cutting, you're threading, supposed to be reaming, we'll say we're reaming too. You're threading. After a while, you're starting to build up a lot of heat, okay? And you're not slowing down because, well, on the job site, guess what? If that machine's not running, if the boss can't hear it or the foreman can't hear it, all of a sudden they're going to come running downstairs saying like, why can't I hear the machine? Okay, once that machine's set up and you're working, they got to hear that machine the whole time. All right, they don't want to hear it ever taking a break. Unfortunately, that's exactly what you might have to do. If you only have one machine, optimally you'd have two machines, go back and forth, several sets of dies, but you don't. You got one machine, usually one drop head, and you're cutting and cutting and cutting. You build up a lot of heat. So we're going to say that within the drop head, we're just going to look at one die, all right? This die is putting threads on a pipe, okay? You're power threading, it's going very fast, you're building up a lot of heat. What happens, if we're going to take an expanded view, is it is so hot on the threads and the pipe that you actually, fragments, little sections, little chips, little, stuff that you're cutting away, it welds itself to the teeth. You'll get little tiny bits of the metal that, usually most of it falls off into the pan with the oil. But, sometimes it's so hot, that these little things stick. Oh, and of course, we're using an oiler, and it's like the oil is meant to take heat away. Okay, that's its purpose. Besides, secondary lubrication, but mostly, just like in a car engine, its job is to remove excess heat. Heat is always your enemy in any kind of machine, that's producing any kind of friction. So now, in the beginning also, the oil is cold, but you're working, you're threading and threading and threading and threading. After a while, that oil is also kind of warm, so that's not helping matters either. These little bits of metal, they get stuck, okay? You don't realize that. All you know is that now, instead of having nice clean threads, you got like bits cut off, maybe a good thread here, etc. And you don't know why. It's because these little bits, and we're going to call them stickers. They are stickers. That is the term for them. You're getting stickers in the teeth of your die. So, If you got an extra drop head, use that one, and then have someone else with a nice fine chisel, kind of like with a nice fine chisel and hammer, and pretend, you know, he's like a jeweler or something, and just start knocking the little stickers off. Because although they weld, they don't fuse beautifully or perfectly. They stick just enough that they can ruin your threads, but with a nice sharp chisel, a hammer, and a little bit of patience, you can get those little stickers off, and that drop head can go back into service. But that's why you start getting these things, you know, and guys will switch over and over again, you know, and they just don't understand what's going on, and it's like, you know, it's the teeth on the threads don't look bad, but it's like, that's not the issue. The issue is now you got to look closely into the teeth and see there's little tiny stickers in there. You got to get them out, and then the dies are good again. Okay, that is not on the exam. That's just something I thought I'd relay because it can solve a lot of problems. And if you're the only guy on the job that knows this and cleans it and solves the problem, you'll look like a superstar, right? Okay. So the table. Length and number of threads shall be as follows. Okay, and the table you're looking at is what we started working here. All right, so we're not going to go kill this table now. We've been over it. But I will remind you guys that in the actual code, the Department of Buildings publication, you'll see we're 1 inch and I have 7/8. That's the correct number. In the table, it's 1/8, and it's like, that's just impossible. That's no way that can, that just defies logic. Now, before we move on, though, just like we did with consolidating information on the flashcard, every time we go through these tables, every time we reinforce something into our memory, we're going to try and save our brain some work, and we're going to do some more consolidation so that now we just keep knowing these numbers better and better and better. You know, we kind of corral them in, we limit how far they can go, we organize them, we make them easy to remember. So here, this is just too much of a repetition again, all right? It's like 3/4 and 3/4, so you know what? How about we just say 1/2 and 3/4, 3/4, right? And then 10, 10, 10. Well, how about we just say 10? Now, of course, 1 inch is different, so 1 inch is 7/8, but we can now do this. We just consolidated the information so that now, instead of these numbers, we have fewer numbers. And these numbers, and you know, we keep, sometimes we don't exactly remember the number, but we have a picture of it in our mind. We remember the table, you know, and then we think about the table and we just look at it in our head, and then you try and read the picture that's in your head, and you'll remember. I remember at the top, the two smallest numbers, they're together, they share the same number. 1 inch, you'll remember, you know, for several, it's a little weird. That's why I always like to start the table 1 and the 7/8 lengths worth of threads, but it shares something with the two smaller numbers, right? You might even remember that, well, you know, Victor kept harping upon that this is where the mistake is in the table in the code book that was there in 2008 and 2014, and you know, I was dying to see if they fixed it into 2020, but we have yet to get that issue. We'll see what happens, right? And now let's see what else we can consolidate. This here, I guess we could go 1.25 to 2 inch, right? We'll try that, and it's 1 and 11, right? Here we go 2.5 and 3, and that's 1.5 and 12. And our lower limit, which kind of helps us fill in the rest sometimes because maybe we're not too sure, but we know We know we can't have any more than, 13 threads. We know we can't have any length of threads longer than 1 5/8. So we'll just say 4, 1 5/8, and 13. All right. This won't be the last time we'll be hitting this table. Every time we hit it, we keep reinforcing, and also maybe we'll find another way to consolidate even more. Keep shrinking this down so that it's very, like, let's say, every millisecond is important, is crucial. Well, you already removed 1, 2, 3, 4. You already removed 4 items you would have to write down. So this table actually takes less time to write down. And that's important when you're starting in the test. If we're going to do a legal cheat, we're going to use the scrap paper and we're going to write out the table while it's fresh in our head before we even start answering questions, and then put it to the side in case we need it. And we will. They are going to ask you questions about this. The faster you can do that, the more time you have for the test. The less you have to remember, the more tables and information you can put on your scrap paper. In other words, we're creating a shorthand. Okay, we don't have to write everything out. It's a shorthand. We just put it all down. We know what it means. That's all that matters. And it's accurate. So when we go refer to it, it's practically like bringing in our own code book. It's like, right? So, underneath the table, pipe dope shall be resistant to liquefied petroleum gas. Yes, pipe dope shall be resistant to petroleum products. We realize that petroleum can eat away at certain things. It's one of the reasons why we cannot use a rubber gasket in a gas distribution system. What we were allowed non-asbestos fiber. We were allowed steel, copper, metal period, and spiral wound metal. Well, that just refers to the high pressure, high temperature gaskets that usually you're going to use in a high pressure steam system, but sure, you can use them in a gas system. Okay. All right, the very bottom sentence, and this will show up on the exam. They will ask you this, but it's not hard to remember. Lamp wick, cotton thread, the thing that you actually see in a candle that you light and burns down. Prohibited, absolutely prohibited. Okay. Page 63. The type of joint employed shall, okay, when we're making, since we're talking about threads, so a threaded joint shall be suitable for the pressure temperature conditions, okay. Remain tight and sound during service, right? It's not going to loosen up. The dope's not going to dry out and become useless. It's not going to loosen up from vibration. Be able to withstand maximum end force caused by internal pressure and additional forces caused by temperature expansion, contraction, vibration, fatigue, or the weight of the pipe and contents. In other words, it's not going to blow off, okay? You thread something on, it's not going to somehow pop off. Pipe joints shall be, okay, threaded, flanged, or welded. Threaded and welded, we know. We've been beating that to death. Flanged, we know because, well, we need to know the particular do's and don'ts of flanges. Tubing joints are prohibited except stainless steel, flexible, multiple leg hose assembly shall be as per the code or manufacturer, whoever, both, and then if there's a conflict, the more restrictive, so if the manufacturer's requirements are more restrictive, they went out. If the codes is more restrictive, they went out. Withstand seismic displacement forces, vibration, earthquakes, be subject to special inspection. So this is obviously a more exotic system, not something that we're going to see every day. Just remember, stainless steel, flexible, multiple leg hose assembly. So this is for something very special. Okay. Flare joints are prohibited, and I put duh. When have you ever done that on gas? In New York City, of course. You go outside of New York City, they're running copper tube and flare joints all over the place. It's amazing, And, well, you know, to each their own. But in New York City, no. Now, of course, once again, but we're not supposed to harp on this, you know, the flexible connector to the stove is not only a corrugated stainless steel flexible connector, and it's just a single one, it's not even a multiple connector. It also depends on flared joints at each end, right? But we're not going to harp on that. We're not allowed that, right? Except in this one particular exception. Here, I printed it nice and big for you. Threaded fittings larger than 4 inches are prohibited. That's the blanket statement. That's it. Doesn't even matter. Now we know that at higher pressures, we can't even use that. You know, over 5 psi, everything's welded. Up to 5, the largest fitting we could use would be a 3.5. If you happen to have it around, you can't use a 4-inch threaded, right? So, but the blanket statement is anything larger than 4 inches is prohibited. Bushings are prohibited. We went over that. You're not allowed to use a bushing, period. Even if it is steel, can't use it. Fittings used with steel or wrought iron pipe shall be steel or malleable iron. Malleable iron is not the same as your cast fitting for a steam system that are chunky. Malleable iron it's iron, but it's been treated, so it has some kind of flexibility to it. It can withstand impact, so you can use it with steel pipe. All right, so steel or malleable iron. Flange pressure temperature ratings shall meet or exceed that required of the application. That's usually standard for any fitting or any material you're using. Always has to be rated to be higher than what it's actually going to be dealing with, the max that it could possibly be dealing with. That's a safeguard in everything. You're never going to use something that is exactly matching the max. It's like we always go a little overkill. Standard flange facing shall be allowed. Okay, so if you have a flange, you know, I guess they're referring to that if you have a flange with a raised face, it's allowed, okay? But if you have a flange with a raised face and you're joining it to a flange that does not have a raised face, we got to take care of that. And this next sentence tells us how, when joining a 150-pound steel flange to a class 125 cast iron flange, the usual flanges you're going to use, you know, we're using standard weight pipe. This is standard flanges for that application. The raised face of the steel flange shall be removed, and we went over that because both sides got to be nice and flat, and you're going to use a full face gasket because the cast iron flange is brittle. We don't want to create leverage points where the force of the bolts is going to crack the flange. Okay? Material for flange gaskets shall be capable of withstanding the design, temperature, pressure of the piping system, the chemical constituents of the gas being conducted. No rubber, right? Rubber can't withstand the petroleum nature of natural gas. The effects of fire exposure on the joint. It's got to last for a little bit. It has to have some kind of fire rating. It can't, like, you know, like let's say, you know, let's get ridiculous and say, well, I got a gasket there, but it's like a really hard wax gasket, and it's like, that's ridiculous. It's like the minute the flange is subjected to heat, it's going to melt right out. So no. Materials for flange gaskets shall be metal, non-asbestos fiber, aluminum O-rings. That sounds like an exotic application. So I guess if we got, well, we're not allowed rubber, but what if we have flanges made for steel pipe, gas distribution system, and they use an O-ring, but we're not allowed rubber? So you use an aluminum O-ring, because maybe you get these flanges that, you know, they're approved and they're nice and they do a wonderful job, ease of installation, etc., etc., but you got to seal it. You know, it's like no rubber O-ring, you know. And spiral wound metal, remember, I looked that up, and that's the high pressure gasket. Okay. Let's see, metal, aluminum. Okay. When a flange joint is opened, the gasket shall be replaced. Okay. And then I give you the phrase that, you know, on the test, yes. What you do in real life, well, you don't want to assume any liability. As long as you can walk away from it and sleep at night and you don't get any calls in the morning, saying you have to answer a lot of questions that, well then, yeah, you replaced it. Yeah. Okay, only full face gaskets shall be used with cast iron flanges. Well, if we had to take the extra precaution of grinding the face off a steel flange when joining to a cast iron flange, well, that implies that cast iron flanges are going to be delivered to you with flat faces. And those flat faces are going to need full face gaskets. Piping shall not be installed in or through a circulating air duct, a trash chute, a clothes chute, a chimney, a gas vent, a ventilating duct, a dumbwaiter, or an elevator shaft. So, remember these 8 items, and when you make your flashcard, in order to, remember we just went over in the last video, you got your card, you write on the front, no piping in or through, or no piping in. Kind of implies through also. If you went through, it's still in there, right? You're gonna write that on the front. On the back, put your little list. How many items are here? 8. So go to the front again, and what I like to do is, in parentheses, I put 8 items. This way, when I'm looking at the card, I know I got to try my best to keep listing out 8 and see if I get close to it. Okay, it helps. It helps when you're trying to recall. And, I don't know if we're going to come back to this one again, but since I'm looking at it, I already see like you don't even need 8 items. You could consolidate by saying circulating air or ventilating duct. That takes care of 2. Chimney, gas vent, and I guess a gas vent, you could have a large enough gas vent that you could run a smaller gas pipe in. Seems a little difficult. I'm going to think of it as a vent connector, the pipe that goes from the flue to the chimney. And you could put chimney, vent, and now that closes 2 of them. Trash or closed chute, that cuts that. And dumbwaiter elevator shaft. Kind of the same. Dumbwaiter is just this little elevator that, the kitchen staff, they put the food in, they close it, they send it up to the bedroom, and in the bedroom, boom, they open it, and there's the food. Or the dining room is upstairs, they open it, there's the food, So a dumbwaiter was an elevator for food. So you could put dumbwaiter and elevator shaft as one item, because they're kind of similar, okay? And if you do that, now, you only have 4 items to remember because you're consolidating every 2 of them. So circulating air, ventilating duct, right? Trash chute, closed chute, chimney gas vent, dumbwaiter elevator shaft. 4 items. That's a lot easier to remember instead of 8. Now on the front of your card, just write 4 items. Okay, downstream piping in one townhouse unit shall not be upstream piping for a second. All right. That almost sounds scary. It's like, if you could do that, wow, that sounds scary. So, we live in New York City. Townhouse, I'm gonna say, let's say townhouse is a brownstone. Okay? And brownstones are attached, unless you're at the end of the block and you can be the one with the semi-detached brownstone. Brownstones are attached all the way. But each brownstone is its own property. So one brownstone, right? We got one brownstone here. And then we got, because they're attached, another brownstone here. Okay. You got gas coming in. And the gas is, you know, it's going to go to the floors, right? And then here you should have a different gas coming in here, and it's going to go to the floors. And of course they're going to have their own meters and stuff and everything. They're separate because they're separate properties. They're built separately. You know, separate. Usually properties. When everything is said and done, the bottom line is the tax on it. Okay, the tax lot. All right. So each one is its own separate tax lot. All right, but for our purposes, we're going to say each one is supposed to have their own gas service coming in. The meter reader, he's got to go into this basement to read this one, this basement to read that one. So, what did we say? If we're coming from the main, we're going in this direction, okay? Let's say this is the meter for the sake of argument. This is the downstream piping. This is the direction, so this is the downstream piping. Going in this direction, this is the downstream piping. The temptation, or just, a mistake that could be made is, because these are semi-detached, you might go like this, okay? Or you might try to go like this, because you're planning on cutting this out. You're planning on not dealing with this, all right? Either way, you're planning on this downstream piping, supplying somehow all of this. You're planning on this is not the supply anymore. This is not the service. You didn't want to connect the service. You wanted to go from here into here and supply the gas to here, right? So now your gas piping is upstream of their appliances, their distribution piping. Your downstream piping for this unit is the upstream piping of these appliances, because you've decided to cut this out. Totally legal. Cannot do that. Every unit, every townhouse is its own tax lot. Every townhouse has its own service. You cannot decide all of a sudden, we're going to go into the next one just because they're together. Okay? All right. Piping shall not interfere with the normal operation of windows, doors, and exit. Yeah, that would. Yeah, you can't install piping and then every time now it's like you can't open a door. Every time you open a door, it's like it's doors, exits. Yeah, I think that's for anything. Plumbing fixtures, anything you do, you cannot. Everything has to operate the way it should. You can't interfere with that. Piping shall not be installed within a stair enclosure or required exit way. Okay, so any stairs you're going up and down, and usually stairs you're going up and down are generally also going to be stairs that you're going to use to exit. So you can imagine, I would think that the best reason for that would be, if these stairs lead to exits, and in a fire, we need to get out as fast as possible, and there's gas piping there, I just think something bad can happen, okay? You shall not have piping in a shaft containing standpipe risers. Yeah, see, this is verging on that we're worried about a fire, and the last thing we need in places where this is where people are exiting and firemen are entering, etc., etc. or just simply the fire protection systems that need to be dependable, we don't want a